Assalamu alaikum. Today I am going to explain some definitions related to topology and functions as well, basic definitions. So first definition is equivalence relation. Equivalence relation definition. So what is the definition of equivalence relation? A binary relation. A binary relation. This is the relation, or as we can say, or is the binary relation between some two sets or two elements as well. A binary relation on a set on us on a set X. Yes, an equivalence relation. Equivalence relation. If and only if. This is equivalence relation if and only if for all x comma y comma z belongs to x it satisfies it satisfy following properties. First property is reflexivity. So what is reflexivity? So reflexivity, if the for all x belongs to x and every x related to itself. So this is the definition of reflexivity. Means this is reflexive relation. Means every element related to itself is reflexive. Reflexivity is old. Means suppose that R is the relation is equality relation, and for all x belongs to the real numbers. So every x is related to x. Means every x is equal to x. This is the example of reflexivity. Now I am going to second property, symmetry. What is the definition of symmetry? For all x comma y belongs to the set, respective set which we are given, if x related to y, means if x is a relation with y, then we have also y is related to x. Means if x is related to y, then y is related to x. Means if x is equal to y, suppose that equality relation implies y is equal to x. This relation is hold at this condition. So third property in equivalence relation is transitivity. Transitivity. So what is the definition of transitivity? For all x comma y comma z belongs to x, if x is related to y and y is related to z, then we then implies that x is related to z. Means if x is equal to y and y is equal to z, implies x is equal to z. This is the transitive relation. If three properties are hold, reflexive property means every elements in this set which we have given, so every element related to itself. What type of relation we are not interested, but every relation, but any relation defined at that set. So every element related to itself. This is reflexivity, and for all x comma y belongs to x, if x related to y, then also y related to x. Transitivity, third property, for all x y for all x comma y comma z belongs to x. So if x is related to y, means x is related to y, x is a relation with y, and y is a relation with z. So implies that x is a relation with z. Now I am going to second definition of injection or injective or one to one, one or injective function or injection function. So what is the definition of this function, injective function or injection function or one-to-one function? So I am going to explain this. First, I write this definition of function f from x to y is an injection or one-to-one or one function f for any if for any x comma y belongs to x, we have f of x is equal to f of y. If f of x is equal to f of y, means f of x is the image of x. Suppose that x is the set and y is the set, and here 2 points x and y. Lots of points. If we choose x and y, any 2 points, and the image of x is equal to f of x, and the image of y is equal to f of y. If f of x is equal to f of y, suppose that if f of x is equal to f of y, means these two images are same, implies x is equal to y. This implies that the previous pre-images are same. If images are same, then pre-images are same. This is the definition of injection function. If the function is injection, one-to-one or injective function, if this condition is hold, so this is called injective function. If the images of two any two elements of x is equal, then implies there must be equal to the pre-images are equal. So this is injective function. This property hold in injective function. Now another definition. Surjective function. Surjective function or surjection or surjective function or onto mapping. So what is the definition of this? I'm going to write this, then explain. The function is a surjection or onto function if and only if for all y belongs to y, there is for all y belongs to y, there is a x belongs to x such that f of x is equal to y. The function is called onto function. Means suppose that this is the set of x and this is set of y, and f is the function from x to y. So for all y, for any y, if we choose any y from y, for all y, this condition hold for all y. For any y belongs to y, there exists x belongs to X such that this condition means this is the this is the image of any X, maybe 1x or more than 2x. This is the definition of surjection function or onto function.